A boiler is an enclosed vessel that provides a means for combustion or direct heating, and transfers heat to water, until it becomes steam. Steam under pressure is then usable for transferring the heat to a process. Water is useful and cheap medium for transferring heat to a process. When water is boiled into steam, its volume increases about 1,600 times, producing a force that is almost as explosive as gunpowder. This causes the boiler to be extremely dangerous equipment, and should be treated carefully. Marine boilers are of two types, namely the water tube boiler, and the fire tube boiler. The water tube type boiler is used for high pressure, high temperature, high capacity applications, usually used for main propulsion turbines, or cargo pump turbines. On a motor ship, a fire tube boiler are used for auxiliary purposes, hence they are called auxiliary boiler.
At 0300 hours Greenwich Mean Time, in stormy conditions, an explosion occurred on board a 10,000-ton motor ship. The cause? A furnace collapse in a fire tube boiler, due to incorrect chemical treatment failing to prevent scale formation. A few days later, a stoppage at sea occurred on a VLCC, due to tube failure in a high-pressure boiler, as a result of corrosion. Thousands of ships of all sizes operate on the high seas with good standards of boiler operation. There are many different types of boilers operated by marine engineers. Why is it then that occasionally disaster occurs? Something goes wrong with boiler operations, resulting in extensive damage, possible loss of life, and withdrawal of the ship from service for long periods. The causes of breakdown may be many, but they can be avoided if the operating parameters of the boiler in use are rigorously maintained. That and good water management will ensure the safe and cost-effective operation of any steam-generating plant.
Direct steam heating system, boiler, require some level of pressure in order to function. For pressure-fired steam system law, in many areas of the country, requires that it must be operated by full-time, licensed boiler operating engineers. With thermal fluid heating systems, all of the equipment is non-pressurized. The thermal fluid heating systems operate at lower pressures, and are vented to atmosphere at the end of the expansion tank. This decreases the risk of dangerous explosions in the facility, and eliminates the necessity of monitoring and regulating system pressure levels continuously. On the other hand, the thermal fluid heating systems do not require licensed operators to run the system. Thermal fluid heating is a type of indirect heating, in which a liquid phase heat transfer medium is heated and circulated within a closed-loop system to one or more heat energy users. Thermal oil, glycol, and water are common heat transfer mediums for these systems. While the basic components of a complete thermal fluid system are the same, the heater designs vary considerably based on the fuel source. Standard and custom heaters are available in gas-fired, oil-fired, electric, and biomass-fired configurations. Many people around the world refer to these systems by different names. The phrases thermal oil heater, thermal oil system, thermal oil boiler, thermal fluid heater, thermal fluid system, hot oil heater, hot oil system, and hot oil boiler generally all refer to the same type of closed-loop liquid phase heat transfer system. Advantages of thermal fluid system. 1. Thermal oil offers the user the capability of high-temperature operation, up to 300 degrees Celsius with organic thermal oils and 450 degrees Celsius with certain synthetics, at very low pressures. Comparing to water and steam, this would require a corresponding steam or water pressure of above 85 bar to obtain the temperature of, for instance, 300 degrees Celsius. 2. Due to the low operating pressure and properties of thermal oil, Most heaters are built to ASME Section 8, and a licensed boiler operator is not typically required. 3. No corrosion or freezing concerns. 4. Simple circuit, no blowdowns, steam traps, or condensate return systems. 5. Minimal maintenance. 6. No handhole gasket replacement. 7. No retubing. 8. No water treatment requirements. 9. If a process requires heating and cooling, it may be done with a single fluid. 10. Safe and more efficient than steam, electrical, or direct fire heating methods. System safety considerations. 1. Thermal fluid selection. 2. Pump and proof of flow. 3. Fluid excess temperature protection. 4. Expansion tank design and fluid level. Thermal fluid system on board. Thermal fluid systems on ships are used to supply heat for various kinds of heat consumers, like fuel oil tanks, heaters, separators, freshwater generator, and fuel heaters. Supply heat all types of cargo such as bitumen, oil products and chemicals. Also tank washing systems, steam generators and central heating systems are typical fields of application. In thermal fluid systems, the produced heat is transferred to the ship's heat consumers, by means of a transfer fluid, usually a mineral oil. Pumps circulate the fluid through the closed system, passing the fuel oil-fired heaters and economizers. The fluid remains in a liquid phase during the entire process, enabling high temperatures with the lowest possible pressures. Advantages for ship owners. 1. High temperatures with low pressures. 2. Fully automatic safety system. 3. Low fuel consumption. 4. Easy operation. 5. Low maintenance costs. 6. Long life of thermal fluid due to the optimal system design.